So hello again, students. We're talking about three-dimensional geometry, and in the second part of the video, we'll talk about distance formula and section formula in the same chapter, right? Let's start the topic. We'll start with the distance formula. Right. Now, in the previous chapter or the previous topic or the previous part, we talked about how to define the coordinates of P in a three-dimensional plane. If you guys remember, it was nothing but x comma y comma z if x and y and z were distances from x-axis, y-axis, and z-axis, right? Now, if we talk about the distance formula, it's very simple. It's way similar to that of the 2D plane. The distance between two points A, x1, y1, z1, and B, x2, y2, z2 is given by AB equals to root. It's way similar. That is difference of the coordinates whole square summation. Y2 minus y1 whole square plus z2 minus z1 whole square, right? Now, if we talk about the distance from origin, it is nothing but let O be the origin and P x comma y comma z be any point, then OP is anyone can derive it. If O is the origin, then x1, y1, and z1 will nothing be 0, 0, 0. So it will be distance OP is equals to x minus 0 squared plus y minus 0 squared plus z minus 0 squared. That is x squared plus y squared plus z squared. It's very simple, right? Now, let's talk about distance of a point from coordinate axis. Sorry, distance of a point. Right? What is this distance? Let O be the origin. Right? And, oh, sorry. We're talking about the distance of point from coordinate axis. So there will be no origin here. Let P, x comma y comma z be any point in space. Right? Let PA, PB, and PC be the perpendiculars drawn from P to the axes OX, OY, and OZ respectively. Then, now, can you tell me what distances are we planning to find? We're planning to find the distances of PA, PB, and PC, right? Because they are the only distance from the coordinate axes, right? Basically, we're talking, if these are three axes, sorry, yeah, and this is a point P, this is O, OX, OY, OZ are three coordinate axes. We're talking about PA, PB, I mean this distance, and the height. So basically, if we take P here and we take it to x-axis, and the distance, this distance If we take P to Z axis, then this distance. If we take P to Y axis, then this distance, right? Distance on the coordinate axis is. So PA will be root of y squared plus z squared. PB is root of z squared plus z. Just simple Pythagoras theorem. PC, nothing but root x squared plus y squared, right? Any doubt, right? Okay. Now, let's move to section formula. I had many questions also for you to solve, but due to time constraint, I'm just here to explain the topic. For more questions, you can directly DM me or contact me in Urban Pro, right? Next question. Sorry, next section. That is section formula. Section formula is very similar to that of 2D, right? Let me define the points. Let P x1, y1, z1 and Q x2, y2, z2 be 2 points, and let R x, y, z divide PQ in the ratio m1 is to m2. Then coordinates of R x, y, z is equals to m1 x2 plus m2 x1 over m1 plus m2, comma m1 y2 plus m2 y1 over m1 plus m2, comma similarly m1 z2 plus m2 z1, let me write it below here, comma m1 z2, comma m2 z1 over m1 plus m2, right? It's very easy. Now, if let me give you several conditions. If m1 over m2 is positive and R divides PQ internally, and if m1 over m2 is negative, then it divides externally, right? Similar things you learned in 2D also, right? If the midpoint of PQ is given by, very easy. In the case of midpoint, m1 and m2 will be nothing but 1:1 ratio. So it will be x1 plus x2 by 2, comma y1 plus y2 by 2, comma z1 plus z2 by 2. x1 plus x2 by 2, because m1 would be 1, m2 will also be 1. Done. Right. So that was it for distance and section formula. Thank you so much, guys, for joining in. See you in the next chapter. Thank you.